a confidence interval for something other than mean, meaning you'll have to do it for a standard deviation, maybe a variance, maybe a proportion. And you all know what that is. What does that symbol stand for? Standard deviation being known, or is there a time when standard deviation is unknown? Why, yes, okay. Almost everyone in here will probably do a problem where you might not know what the standard deviation is, okay? Unless you actually look up on Google and find out. But so don't freak out by all this, but we're gonna take a few quick notes and I'm gonna give you 2 formulas and then we are going to do these 3 problems that I assigned you today. Okay, so first things first, before we go on any further, I want you to understand what this word interval estimate is. An interval estimate. Here we go. It is used to estimate the parameter, and I know I'm going to have to explain what that means. We've talked about it before, but I'll explain again, as being between 2 values. An interval estimate is where we use to estimate our parameter being between 2 values, okay? Here's the things you would say. Like, I am 95% confident that the average test score in the other class was, on the last test, was between 80 and 100. I'm 95% confident that it was, okay? And so I would set out proving it to you and showing my confidence, okay? Maybe you've heard it with the election that just happened. I'm 95% confident that the state of North Carolina voted for Biden between this percentage and that percentage. That's what they would say, okay? So they'll use these words like, I'm 95% confident, I'm 99% confident, I'm 90% confident, okay? So the parameter could be one of 4 things. We're going to talk today about it being a mean. That's our parameter. We're going to say the average on the test score, the average on a timed running track thing. That would be what we're talking about, mean. We could do standard deviation, obviously. We use a different formula for that. We could do variance, which again, how are those 2 related? Do you remember? Square root and squared. Okay. And then we are going to do this one called a proportion, which normally proportion we've learned before was like percent, but we're going to do a proportion and find the confidence interval for that one. Okay. So that's what we're going to talk about today, is this interval estimate. Now, what would be the confidence interval? Confidence, making sure I'm spelling correctly. The confidence interval is the probability, that chance that the interval estimate will contain the parameter. Will contain the mean, will contain the standard deviation. The chance that the interval estimate will contain that parameter. Okay, so there are really 3 types of confidence intervals. You could do other types, but more than likely it's these 3 types all the time, okay? If you're going to find out for a 90% confidence interval, you are going to use a z, alpha over 2, just write that and I'll explain what it means in a minute, of 1.65. Okay, for 90%, 1.65. That's your magic Z. For a 95% confidence interval, your Z alpha over 2 is 1.96. That's the magic number for 95%. And Oops. If you want to be 99% confident, your Z alpha over 2 is equal to 2.58. Now, where are they getting these from? That's what actually you've been working on prior to this. Let me show you and explain. So we are going to find an interval, an in-between, okay? Let's say I want to be 90% confident, right? 0.90. But whenever you found an in-between and you did that in your calculator, did you inverse norm that 90 when it was an in-between on the last test? No. You inverse normed what? You inverse normed that guy, didn't you? Okay? Which, how much would this be, by the way? 5%. 0.05, 0.05. Okay? And you would find that Z. Well, what they're doing is they're calling this your alpha, which would be the 10% here, and they're dividing it by 2, and they're calling it 5%. So don't freak out by this new crazy notation. It's pretty much what you've been doing, and it's the same thing. But if you plug this into your calculator and you found it right here, I promise you would get, well, for this side, you would get negative 1.65. But we don't need to worry about that because the one over here, Z alpha over 2, is equal to 1.65. Look at that. 1.65. Okay. So these are the 3 types that you're always going to have to use. If they ask for a 90%, your Z alpha over 2 is 1.65. If they ask for a 95%, your Z alpha over 2 is 1.96. If they ask for a 99%, your Z alpha over 2 is 2.58. Are they going to ever ask for an 80? They might. I'm trying to think, but more than likely, no one says, like, I want to be confident 80% of the time. You don't want that. Okay? You want to be confident 90% of the time. You want to be confident 95% of the time. You want to be confident even 99% of the time. That's even better. Okay. As a statistician, as a person who tells people like in a big corporation, hey, I'm 99% confident that, the amount of, I'm trying to think of an example, pens that are coming out of the factory that are working are working well kind of thing. You want to be able to tell them that in a factory setting. All right. Now, with all that being said, all this to say, here's the formula for today. And everybody has it differently. So if you use, that little thing called Slater, they probably have a different formula. So I will obviously know if Slater has been used. But no one in here uses Slater. No. I know.
I want to learn another way to do it.
Yeah, I'm sure you do. All right. This is the formula for a confidence interval for a mean. This is important. For a specific alpha. That's what they're just calling it. Don't worry about that. When sigma is known. Okay. What a crazy long title. But that's the title of it. Formula for a confidence interval for mean for a specific alpha when the standard deviation is known. Again, this makes you look smart. All this stuff that we're about to write. So here's the formula. Write it down, and then we're going to just quickly talk about it. And you're going to look brilliant. You show your parents this, they'll be like, my child don't need calculus. Look how smart they are. Mm-hmm. There it is.
Oh, that's all?
That's it. You are the Einstein. You are the Einstein. Come on, you know all these symbols. Don't freak out, okay? You have seen this before. For example, what is X bar?
That's the sample that you got.
That's the sample's, in this case, mean. Good job. That's your sample mean. So they would have to, in your story, say sample mean of these 20 cars on the lot. I took a, mean average of how much their gas tank can hold, that kind of thing. That's what sample mean right there. Okay. All right, I just told you what that guy is going to be. What are the only three options that Mr. Z alpha over 2 can be? 1.565, 1.96, or 2.58. Other than that, I promise you, on a test or quiz, I'm not going to give you an 80% or an 85%. We can do that, but no one ever says, I'm 82% confident. You're a moron. Okay? No, we want 90% confidence. We want 95 and 99%.
Wait, so if it's like 90% confident, you have the negative 1.65.
No, you just keep 1.65. The negative is coming from here. See this sign right here? And then that sign right there.
Yeah.
That's exactly right.
Negative, positive.
Okay? 1.96 and 2.58. Okay, what is that guy right there? You know it. Standard deviation. They're going to give it to you because it's known. They have to give it to you because it's known. And then we know what that n is. What's the n? It's always what?
Sample
The number of sample size. Yeah. So guys, this isn't that hard. Number in the sample. So here's what this is saying. I'm saying that the true population's mean has got to be in between here and here. That's what I'm going to give to my, as my answer. My true population mean is somewhere between here and here. That's all you're saying. This interval to here. All right. So take out that example sheet that I just gave you. We're going to do 3. Oh, wait, before we're going, I'll give this to you in a minute. We're going to do the first 2. That's right. And then I'll do that.
Well, wait, do I need on our calculator?
Yes, sir.
Cool. Little, like,
Nope. No. You have to do it without. You can do it without.
I'm sure it's some second bars.
Oh, you're getting smarter. Getting smarter.
And
All right.
just gotta find it.
So bringing a calculator to class is important. Interesting. Okay, I just am rewriting this at the top just because I don't want to keep going back and forth to my notes. So, number 1, a researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevrolet Aveo. I don't even know if they're making them anymore. I doubt it. A random sample of 50 cars, okay, that's going to be one of your numbers. A random sample of 50 cars had a mean time on the dealer's lot of 54 days. Assume the population standard deviation to be 6.0 days. Find the best point estimate of the population mean and the 95% confidence interval of the population. So again, you're reading this, you're like, what the heck? You all know these numbers, okay? Let's start up here with a random sample of 50. What does that? Is that my N? My X bar? Isn't that my N, right? I took 50 cars off the lot. 50. Usually your 50 things, it's like 50 people or 50 things is your N, okay? A random sample, look at the next sentence, had a mean of 54. So what would be that? X bar, 54. Okay. Assume the population standard deviation. Obviously, that is good old sigma. And then find the best point estimate for the population mean at the 95%. So that means my Z, I should have put alpha over 2, but I just didn't have the script for it. What would that be? 1.96. You are now going to plug all that in. So X bar, 54, minus Z, 1.96. Times sigma 6 over square root 50. Less than, and then over here you do 54 plus 1.96 times 6 over square root 50. Now, what I would say to do then when I go to my calculator is I would do that part first that has the 1.96 because then you just add it and subtract it to 54. Here's what I mean. Here's what I do. So I take this portion right here, that 1.96, I go 1.96 times 6 divided by the square root of 50. Notice I'm putting it in parentheses just like it is in the formula. And I get 1.66. I would go to 2 decimals. Actually, I take that back. I go to 3 decimals and then I end in 2. I'm sorry about that. I go to 3 and I end in 2. So 1.66. So what am I going to do with 1.66? subtract it, 1.663 actually. I'm going to subtract it from 54, and then I'm going to add it to 54, because this is the same thing on this side. So add that to 54, and I get 55.66. And then subtract that from 54, and I get 52.34. Okay, now let me explain what this means. That right there is your confidence interval. And what you're going to not like is this next thing that you have to do. Part of being in statistics is you can explain what the numbers mean to the big corporation. Like you can't just say, oh, well, it's 52 to 55. 52 to 55 what? 52 to 55 what? Days
Car stays on the lot.
that the car stays on. You have to give them a little bit more. So here's how you start your sentence. And by the way, you're only confident that the population is here 95%. You're not confident 99%. So here's how you always start your sentence. You say this: with 95% confidence, and yes, you have to say it, the mean, because that's what we're talking about, mean, really, I just look at the last sentence. The mean number of days to sell a Chevy Aveo was between 52.3 and 55.7 days. And yes, you have to say the sentence. Sorry. Okay, it's very important. This is your confidence interval. You are explaining what those mean. You can't just say 52 what? 52 eyelashes, 52 what? What are you talking, iPhones? What are we talking about? We're talking about days that this Chevy Aveo was on this car lot, okay? I'm 95% sure that it'll be between 52 days and 55 days, okay? And that's what you give to the corporation. Not too bad, I don't think, right? Let's try another one. A large urgent care center with 4 doctors, found that they can see an average of 18 patients per hour. Assume the standard deviation is 3.2, a random sample of 42 hours was selected. Find the 99% confident interval for that mean, okay? So let's again, sorry this got cut off. This is X bar, this is Z. Tell me something you know right now on the side over here. What's your X bar?
8 or 18.
18. Large urgent care with 4 doctors found that they can see an average of 18 patients. So yes, X bar is 18. Assume the standard deviation is 3.2. So what gets 3.2? Sigma. A random sample of 42 hours. So is N 42 or is N 4? 42. When you're taking a sample. So that 4 is actually nothing to me. It just talks about it. They might add that in the information. So don't get freaked out when you see that. Hey, and what's my Z then if I have a 99% confidence? There you go. Okay. So 18 minus 2.58, your Z, times your standard deviation divided by the square root of N. Tell me what you get. I'll give you a minute to kind of figure this out. Okay, so I got 1.274. Is that what you got? So 18 plus, or well, that would be minus on this side, minus 1.274, and then 18 plus 1.274. So I got an average of 16.7 days again to 19.3 days. And so here's the part, and I will take off points on the quiz if you don't say this. You can start your sentence in these two ways. You would say, with a 99% confidence, or you say, I am 99% confident. Either way is fine with me. So this one I wrote, I am 99% confident, because you are the statistician telling us this research. I am 99% confident that the mean, what is our mean about? What is our average about? Patients per hour, that the mean patients per hour, it's all up in there, so you should be able to read it, is between 16, and again, can you have 0.7 of a patient? Well, it's just accuracy, that's all. Is between 16.7 patients and 19.3 patients. Okay, I'm 99% confident that this hospital particularly sees around 16 to 19 patients per hour, okay, with these 4 doctors. That's a lot. That's a lot of patients, actually, not only. That's about what, 4 an hour, roughly? 4 or 5 per doctor? All right. And then last but not least is actually based off of a new formula that I actually want you to write down for me. This is, go back to my notes real quick, and I just want you to write this formula. And this is actually an easy formula. And that's what this one will be about. Formula for minimum sample size. Formula for the minimum sample size needed, sorry for the long titles, for an interval estimate. Woo. Of a mean population. So sometimes you're going to do a project and you need to know what's the smallest sample size that I'm going to need if I want to be 99% confident. Okay. Oh, just 10 people? Oh, I'll just do 50 people. I'll just do 100 people. Okay, but you don't necessarily need 100 people. You might just only need about 30 or something like that. So you want the minimum number that you need to be 99% confident. So this is your N. This will actually, you will figure out what is my minimum N sample size that I need. Z alpha over 2 times sigma divided by E, which I'll tell you what that means, and then square that number. Okay? So you all know what this guy is. That can only be 3 numbers, 1.65, 1.96, 2.58. So that one you'll know. This one is your standard deviation, so you're going to obviously know that. Okay? This E is called margin of error, which they give to you usually as a percent that you need to change into a decimal. Here's what I mean. Again, the election was really good. I don't know if you've ever heard of them, like, have you ever heard of like plus or minus 5%? Have you ever heard them say that before? Plus or minus 2% of the population voted this way. Okay, that's what's known as our margin of error. Okay, so they will give this to you again in the sentence that it says, and then that'll tell you the lowest amount of people that you would have to survey. So let's, again, sorry about the going back and forth here. I just wanted to write that down, not to confuse you, but going back to our last example, sociologist wishes to estimate the average number of automobile thefts in a large city per day within 2 automobiles. Okay, now, of course, this one changed on me. They didn't do it in percents. They did it in actual number. So thanks, example. He wishes to be 99% confident. And from the previous study, the standard deviation was found to be 4.2. So how many days should he select to do his survey? So here's what we're looking for. We're looking for N. We need a Z alpha over 2 again. We need a standard deviation. We need this error, usually written as a percent, but in this case they didn't, so thanks a lot. Sorry, it always changes. It's math. All right, so you tell me, what would be Mr. Z alpha over 2 and why? Why is it 2.58?
So he wishes to be 99%.
Because it says he wishes to be 99% confident. Exactly. Okay. What's my standard deviation? 4.2. And what is my error? If it's not a percent, then just give it as the whole number, which in this case was 2. Okay. So you are going to do 2.58. Be very careful on your math. Times 4.2. Take that number, divide it by 2, and then square it. And tell me what you get, roughly. 29.35? Okay. Here's the only new thing, and then this is the newest thing you have to do. No matter what this decimal is, no matter what, you round that answer up. What if it was 29.04? Round it up. What if it was 29.00001? Round it up. So how many days does this surveyor, sociologist have to go for? 30 days. No matter what, always, always, always round up. Because you don't want, you can't be like, especially if it's people, you can't be like, oh, I'll just survey 29.56 people. No, just survey 30 people, okay? So that is it for today. You have a worksheet of whopping 4 problems, I believe. Yes. And 2 of them are confidence intervals, and 2 of them, I think, are the E stuff. So don't worry about where it says sentence for the E. That was just me being cool and recopying and moving on. Fine. So the first 2 are confidence intervals. The second 2 are E's, so don't worry about where it says. And then tomorrow I'll show you how to do it in the calculator. You're welcome.
That'll be exciting.
It will be exciting because you will look so smart.
I will. And then I can show John.
Then you can show John and be like, John, you can't even do this. We all need to mock John. That's part of our goal.
Bad.
Mocking John. True. Hey, you guys got 10 minutes. You could probably finish this. I was going to say, I was like, wow.
Are you doing it?
Wait a second.